Okay, now I'm starting now. Oh, one more guy. Wait. So actually, our fourth and fifth model is related to industrial wastewater. Industrial wastewater treatment. It starts with that for in the fourth model. And fifth model, they are given you specific industries and how they will treat their wastewater. So fifth model, you have that. So fourth model is related to industrial wastewater treatment. So I think if you have seen the syllabus, it will start with. Wait, I take you to the syllabus. It's in mobile. Yes. So fourth model, they are telling more on general way before going to the industrial exact treatment to treat the wastewater by giving some modification how you can reduce the wastewater which is releasing, how we can reduce the total quantity of the wastewater before we practice the treatment for that in the initial starting only. Maybe it may be in the manufacturing of one process, reusing of water which might not polluted in another purpose, like that. How you can reduce the waste before we go into a process of treating it. So that whole general concepts of things they have, you'll be studying in the fourth model. Okay. So yeah, so like volume reduction, you have strength reduction, neutralization, equalization, and proportioning. you know those things will be there and in the fourth model. So these are general concept: volume reduction, strength reduction, neutralization, and equalization, proportioning. These are coming. And after that, in this model, you will be learning on some, you know, a few more methods to remove few impurities like colloidal solids, uh, inorganic solids, organic solids. I think those things you already know in the biological unit. You have learned many things. That thing only you'll be learning as a part in this fourth model. Like you have to list on briefly you have to explain. If you want to remove only organic matter, what are all the methods available? You already know trickling filter is there, activated sludge process is there. So those things you have to explain. And inorganic matter, if you want to remove inorganic matters in the wastewater, what are all the methodology you might follow? So those things you'll be learning in the fourth model. Okay. So yeah, I think I will start now fourth model. uh, okay. So before that, your fourth model start with some introduction. What is the difference between industrial wastewater and your domestic or municipal wastewater? What is the difference is there? So it start with that. So I will be doing from that. What is domestic waste? You all know is from house, the residential house. It will be released mainly. So that waste we called as domestic waste. It's here. So what it contains, you have to tell when you're talking about domestic waste. Domestic means it's completely. You have to leave all industrial wastewater completely purely from houses or any commercial malls. It might be. So those waste, the sewage waste coming from that is called domestic waste. So the sources they have listed out here: water closet, bathroom, kitchen sinks, like waste basins, residential and commercial. You know, those things are like in apartment, hotels, hospitals, shopping malls. So the waste generated from this we call as domestic waste. So you might expect this question. Just they will try to ask what is the difference between domestic waste and industrial wastewater. Okay. So then, what industrial waste contain? What, why, how it different with respect to domestic waste, they might ask that also. So I will talk about that now. Wait, I will try to do this. Industrial wastewater. So as you know, we have a lot of industries in Bangalore. Also, Pina Industries is there, Silkboard. There also some small scale industries are there, and it's all polluting your lakes, Bangalore lakes, like Bellanuru. You have Vartika Lake. You have lot of lakes are polluted because of what? When you analyze, when you do testing and all, you will see mainly a lot of waste coming from industries only. They are becoming responsible for polluting the rivers because the methodology that we have to adopt to treat this industrial waste is different, and it's sometimes it costly also. That is why many industry will not do that, because it will add some additional cost to it. So that is the thing why we are seeing a lot of lakes are polluted. So we will talk about this now, what industrial waste contains and where it start, how it will originate, those things. So industrial waste contain waste originating from industrial processes. It might be one process or a lot of process might be there, like various industries. For example, you have paper industry, textile industry, you have brewing means the thing which manufactures alcohol. Brewing industry we call, so that, and dyeing industry, color manufacturing unit, like that. So in the process, what are all the waste that is coming from processes of different industry we call industrial wastewater. So the industrial wastewater depends largely upon the type of industry. This is important, and the chemical used for manufacturing. They also use chemicals, right? So what are all the chemical used, that only coming as a waste. So that is important, and type of industry is important. Sometimes they may be very foul, means smell and all, it may be very foul and may require extensive treatment before being disposed of to public sewage. Okay, so extensive treatment is required. So why they don't do means it going to add some additional cost for industry. So they are all in the wars of profit, right? Every industry, they go for profit, so they don't treat the wastewater. They simply discharge to rivers or lakes. That is why your lakes or any rivers, mainly what happens is every industry will establish its unit near to river bed, wherever water available there, wherever water rivers is there. No, there only the industry will establish, so that they can use the water, and they don't face any problem, right? They all take up the water from the river through intake tanks. You already studied that intake tanks will be there. So they use a lot of pumps. They will take up all the water. They build own reservoir inside the industries, so they start using that, and eventually they discharge all the waste there only. Okay, so that's the introduction for this. Okay, so we'll move on now. What are all is there? Yes. Actually, I started 15 minutes late, so you might have to rejoin. I will give you 5 minutes break, because 30 minutes, 20 minutes, I can't do anything. I have to cover your internal portion at least. Okay. So you got to know what industrial waste now and domestic waste, and what is the main cause, or why we have to actually, why you have to study this industrial wastewater means this is the purpose, because most of them are polluting because of these waste, right? Domestic waste doesn't have much pollutants. Most of the time your rivers can purify it, but when you analyze the water, when you test it, you have specific test for some chemicals also, like phosphorus. You have a calorimetric principle we call, it's very costly thing. And we have atomic spectrometer, that one more instrument we have. From there we can analyze so much metals or any of the pollutants in the wastewater. We can find it out by atomic spectrometer. So mainly the rivers are polluting because of this industrial wastewater. So that is why you have to learn it. What is the principle? How you can reduce this waste and those things. So one more concept you have: effect of effluent discharge on streams. Effect of effluent discharge on streams means if you discharge this industrial waste, what affects or what river will get problem, what all the causes you can observe. That is the effect. So I'm doing that now. See here, if industrial wastewater, if it is discharged into any stream or any river, first thing what you will notice, you have already learned in self purification process, what happens, the river has its own dissolved oxygen, but due to this introduction of industrial wastewater, the DO will start depleting. Means it will come like this. It will completely go down your DO level of the river. So that is first thing what happens, right? So you all know this, I think. Next, what happens then? This is due to settlement of the suspended particles and subsequent decomposition of the some anaerobic condition will develop. Uh, i- so that is they are given the alkalinity and toxic substances. Chromium affect the aquatic life and also found to be toxic. Color often reduces the waste unfit for the use, and they are giving each of the chemicals in a broad way. What and all each one will affect. If any chromium substance is there in industries, obviously it will affect the aquatic life. We have bioaccumulation. I think one more. It comes in your pure environmental science, but you will not learning in environment engineering that topics and all. We call bioaccumulation, where your fishes, even you eat vegetables, no. So the water that they use for growing up the vegetables, that only you are consuming. So there is a chance of bioaccumulation, means pollutant entering into your body. That is why you are seeing kidney failure, heart failure, kidney failure mainly. Why means our body cannot filter all the toxic substances that coming out by eating fishes, which is already toxic, or even the vegetable that we eat. The water that they use for growing up, those things also contain some toxic substances. So these all effect we are seeing day by day, right? So they in this PDF they are giving what each of the ways to how it is affecting. Few of the only they are covering up, not everything. Mainly you can say it affect aquatic life, the chromium, and the color often renders the water unfit for the use, right? When you see industrial wastewater, you directly discard it, right? You don't use it. The color only it will show up. Then the presence of sulfide means it's very dangerous. That makes water corrosive, particularly to the concrete structure. If any concrete structure is there near to that area, or if they build any dam or anything like that, or any of the passage where bridges are built, so there if any sulfide content is there, what happens, it will get corroded, right? The building get corroded. That is why the technology also they will build like sulfide resisting concrete, uh, acid resisting concrete. Many are there, many research works are going on based on the condition that we are seeing. Okay, so the presence of sulfide makes waste corrosive, particularly to concrete structures. All treatment plants should be clean, giving serious consideration for the reduction of waste volume and wait, I will zoom it, and chemical recovery and recycling of the waste pollution load from the toxic mill to deal with operation like segregation, neutral. Those things only you will learning in this model. Whatever I'm telling now, chemical substitution, chemical recovery, volume reduction, strength reduction, uh, what and all they have mentioned in the introduction part, those things only you will be learning more on it with this model. Okay, so many things happens actually. Chemical oxidation and biological oxidation, several chemicals are used to reduce BOD by chemical coagulation such as alum, ferric sulfide, ferrous sulfide, ferric chloride, H2SO4, lime. Means this all you'll be learning in the neutralization process. They have listed out few things here. Those things only you will be learning throughout this module. Okay. So what else? That is industrial water. What happens to the rivers? Now one more concept you have. I'll clean this. Okay, one more concept you have. What happens to your sewer network if industrial wastewater discharge to sewers? Means pipes, pipeline you have, right? Concrete pipe. You have already learned different pipe, sewer pipe materials. Steel, it might be concrete, it might be plastic or polyvinyl chloride. So many things are there. So what happens to this sewer network then when you discharge the industrial wastewater? So best first thing you will see is chokes in the sewer due to the depletion of deposition of the solids, but also reduces the cross section of the sewer arising out of the incrust incrustation. Means it will start depositing. If any alkaline waste is there, it will deposit. It forms scaling, right? So sewer pipes getting clogged or chokes will form, right? If any alkaline waste only continuously passing through this sewer pipeline, so you will observe choking problem. So those effects are there. So next, chromium compounds in excess of means excess of this range disturb the operation of trickling filter. Directly any chromium of industrial waste coming out to a normal treatment plant like BWSSP, you have, right? So what happens to these plants? It has designed to operate for specific condition only, right? It has designed to operate for specific condition. So if any industrial wastewater is coming out, the plant also face some problem. Like you have already learned trickling filters, the biological unit, this also get affected if any chromium compound comes there. Okay, then sulfide also toxic in the microorganisms are removed along with the sludge. The sludge is dried out. Means how they are going to remove this, they are given here. So what are all the methodology they have listed out here. You'll be learning more on this in this model. Starting, they have given out what are all the problem and few think how you can reduce that. Okay. So we will go to the exact procedures. I will start now. This is just a introduction. They will ask this actually. This is general concept, but you might face this. The question in video, what they will ask is, what is the effect of industrial wastewater into rivers or any streams or any lakes? What are all the effect you will face? So that is the question they will ask. Okay. So this is what some limits. You already written all this thing in your record, I think. So here also it's coming. So you might have to remember this for your Viva. I think you already written all these things. This is nothing but your, this is IS standard. It is how much the limit has to be there. For BOD, it has to be 30. Within 30, it has to be there. For a normal domestic weight, it has to be 20. Like that, many, I think you already commented on few experiment, hardness, alkalinity. So those limits I'm showing here. So if any one thing, comes up as an excess, then the whole, you know, process completely changes. The river get polluted. So many problems will face. Now, as a preliminary way, how you can reduce this waste. So that is I'm talking now. Before exactly facing any problem, what are all the methodology you can adapt? Okay, those things I'm starting now. Okay. So first we have a volume reduction. I will directly go to the textbook. These all notes by Chandini madam. I think she has written, but I will take you to the textbook here. One more I have. That is very good. Means a lot of explanation there. This is the textbook. You can refer notes or you can refer this. Okay. Means around 10 to 12, 15 pages. Something like this I have given you. I think I already sent this. This is very good when you're going to study in the first time. When you're going to study the fourth module, I will request you to go through this only. After studying this, then you can go to refer to the notes. Okay. So what I told, they have written very nicely here. Very much more they have explained here. What all the pollutants they, but they have made notes reading these thing only. A few things only they have copied. Okay. So when you read like that, you might miss few things. So I will suggest you to go to this only. At the end, I have provided this section to you. Okay. So this is you have learned already what happens to reverse. I think, yeah. So this is your syllabus. I think I have written in the bottom. Effect of discharge on receiving body. This question they might ask. You have stream standards is nothing but your IS code. I already shown you that. Then you have sampling types. Sampling types you have learned in the auto treatment. Graph sampling, composite sampling, integrated sampling. Those things I think you know that. Here also they have given you in this PDF. You can refer that sampling types. Okay, so and this is also there in your syllabus. Removal of organic dissolved solids and inorganic. So this is your fourth model. Okay, so actually when they ask you that main question, effects on streams of this industrial wastewater, if you want to score more marks, then you have to explain like this. See here how they are explained here is they are taken into account of particular waste rather than generally telling it. How they are explaining here is they are taking these pollutants with respect to each one of this. They are explaining what happens to the streams, what happens to your river. First they will start with inorganic salts. They're starting here, what happens to that. Then acid and alkali, if any acid and alkali present in the river, what happens to rivers, like that. In organic matter, what are all the causes. Suspended solids is there, what are all the causes to rivers. So like that they have explained. So I will give you 5 minutes break now, because hardly I have 10 minutes. So can you rejoin now?
Yes,
Because
sir.
take 5 minutes break, I will start on this thing. Okay,
Okay,
because
sir.
you people join very late, so take 5 minutes break and I start explaining all these things once again. Okay. Okay, then I will end the session. Please join 5 minutes later. Okay.